everyone, and welcome back to Activity 21. Today we are going to talk more about some examples for simplifying our trig expressions. Now, as a warm-up, going back to your prior knowledge, if you are going to add fractions together, what you need is a least common denominator. So in our first example, we have a common denominator of 5, so we can just add our numerators. 2 plus 1 is 3, so 3/5 is our final answer. In the second example, however, they do not have a common denominator. 4 and 5, the least common denominator we can make them into is their multiple of 20. So what we would have to do is the first part, 5 would need to be multiplied by 4 to get a common denominator of 20. And what you do to the denominator, you must do to the numerator in order to keep that fraction equivalent. And then same idea with the second part, we would need to turn 4 into 20 by multiplying it by 5. What we do to the numerator, we must do to the denominator and vice versa. So in this case, it would become 5 over 20. And now similar to the first part, now that we have that common denominator of 20, we can rewrite it as a singular fraction. 8 plus 5 is 13/20. Well, so this is going to kind of lead into what we are doing with our trig. So going back to what we talked about yesterday, if we turn cosecant into its reciprocal, cotangent becomes cosine over sine, and then we have cosine of x. Notice these have a common denominator in LCD this time of sine of x. So we can rewrite this now as one singular fraction because they do have that common denominator, and we can make the numerator 1 minus cosine times cosine, aka cosine squared. And then cosine squared can become sine squared, and 1 minus cosine squared becomes sine squared, and then one of the signs from the numerator can cancel with the sign from the denominator, and our final answer simplifies to just be sine of x. Now this is going to play into today's stuff. So some reminders when it comes to simplifying. We always want to simplify the expression as much as possible using those hints from yesterday. Using your identities, turning things into sine and cosine, etc. We also are going to add in adding and subtracting fractions. So again, we need a common denominator each time if we are adding two fractions. So we must make sure that occurs. And then we can always simplify from there by adding or subtracting, depending on what they're asking you to do, the tops and keeping that least common denominator in the bottom. We want to simplify then from there the expression as much as possible, similar to what we did up above. If there is a fraction with a binomial in the denominator, aka two terms that are being added and subtracted, a couple things we have to be careful of. Sometimes we end up multiplying by the conjugate of the denominator. A conjugate is just the exact same values. We just change the middle term to either be from a positive to a negative or vice versa. And then sometimes we end up having to expand it out by foiling. Sometimes you see that double distribute idea I threw out or like expanding. Okay, reminder, there's not always just one way to do a problem, and we will see a lot of different methods, and there are oftentimes more than one that are going to work out. So let's get into some examples. Okay, we see that secant for this first one is 1 over cosine of x, and tangent is sine of x over cosine of x. Well, in this case, we have the LCD of cosine x already, so we're able to rewrite this as one singular fraction all over cosine. 1 plus sine would be our numerator, and in this case, that's as simplified as that one is going to get. Nothing more we can do there, and sometimes that happens. As far as cotangent goes in the next example, we can rewrite that to be cosine over sine. Now the problem with this one is when we rewrite this as cosine over sine, there is not a common denominator. So what we would need to find is our least common denominator this time, which since we can't make sine into cosine or vice versa, we would just multiply them together. That's kind of the least common multiple between the two for our least common denominator. So in order to give each of these a denominator of sine of x times cosine of x, because again, that's what we want to ultimately be able to do is both of these have that common denominator. The first one, we would have to multiply top and bottom by a cosine of x, because then that would give us the common denominator. The second one, we already have a cosine, but they would need a sine of x for each. So cosine times cosine would be cosine squared. Sine times sine is sine squared. And now we have that common denominator so that we can rewrite this as one singular fraction, cosine squared plus sine squared as our numerator. This then, the numerator, is equal to 1 from the Pythagorean identity. And last but not least, we can make cosine and sine come to the numerator by using its reciprocals. 1 over sine is cosecant. 1 over cosine is secant. So secant times secant is our final answer there. All right, next example, notice again, we do not have a common denominator because 1 is a minus, 1 is a plus. So this time, our least common denominator between the two of these is just going to be them multiplied again, similar to the last one. So cosecant of x minus 1, cosecant of x plus 1. Now, in order to get them each to have that common denominator of cosecant of x plus 1 and cosecant of x minus 1, the first one already has a cosecant of x minus 1. So its numerator and denominator would need to be multiplied by cosecant of x plus 1. Over here, this would have to be multiplied by cosecant of x minus 1. So 1 times cosecant of x plus 1 is just going to be cosecant of x plus 1. And then on the other part, 1 times cosecant of x minus 1 is just going to be cosecant of x minus 1. So we have that common denominator now. We are able to write these as one singular fraction. And notice in the numerator, we have a plus 1, but minus 1. So those cancel out. And we're left with 2 cosecant of x's. And then the denominator, if we expand this out, cosecant times cosecant is cosecant squared. Cosecant times 1 is cosecant. And then we're also going to distribute out this negative 1 through. So minus a cosecant minus a 1. Well, similar to up above, these are actually going to cancel, right? Cosecant of x minus cosecant of x. And we're left with 2 cosecant of x divided by cosecant squared x minus 1. Now, it is very tempting at this point to want to cancel out those cosecants. But notice this is not just being multiplied, right? It is being subtracted. So instead, what we're going to do is we're going to use a Pythagorean identity, and we can substitute in first cosecant squared x minus 1, cotangent squared, and we are left with then 2 cosecant, which we could write as 2 over sine. And then we have that cotangent squared, which officially could be rewritten as tangent squared in the numerator. And then if we keep going, we have 1 over sine of x, or 2 over sine of x. Tangent is sine squared over cosine squared. And then we have pieces that'll cancel, right? We have 1 sine here with 1 of these. And then last but not least, the 2, and then we have a cosine on the bottom. We have 2 sine over a cosine that can be officially rewritten as a tan. And then we still add 1 cosine on the bottom if we use this sine and one of the cosines. So the other cosine can then be rewritten up top as a secant of x. So 2 tan x secant of x is our simplified answer there. All right, now the next one is a great example of where we are going to possibly want to look at multiplying by a conjugate. Now, why are we going to multiply by a conjugate here? Well, because there's nothing else we can do down here besides that to simplify. Otherwise, we would just say this is as simplified as possible. Now, what multiplying by the conjugate does, kind of like we actually saw up above here, is what's going to happen is these middle terms are always going to cancel out. So when we double distribute, we end up with 1 times 1, which is 1, and then times positive cosine times negative cosine, which cancel out, and then we're allowed to just do cosine times negative cosine, which turns in for us to negative cosine squared. Now on the top, they're not conjugates. We have sine of x and then times 1 plus cosine of x happening up there. Now 1 minus cosine squared, we know can be rewritten as sine squared. And then in our numerator, we had sine of x times 1 plus cosine of x. The sine in the numerator can cancel with one of the two in the denominator. And then we have 1 plus cosine over sine. Now, sometimes we can look at this as being broken up into two separate things, right? We went from having a common denominator to not a common denominator. And in this case, if we break this up into two separate fractions, 1 over sine of x can become cosecant of x. Cosine over sine can become cotan. All right. Let's see. Next one down here, we're going to skip over number 5. Let's look at number 6. Number 6 is almost an example of where we almost want to just check these out like they're two separate problems. For instance, in the first part of number 6, we are able to take 1 plus tangent squared, and we are able to make that just into using a Pythagorean identity, secant squared. Instead, they're using a t, not an x. And so in the top, we have secant squared plus, of t, and then plus secant squared t times cotangent of t squared of t. Now, what we're going to notice is that these have a GCF, right? We can divide out secant squared t, and we are left with 1 plus cotangent squared t. 1 plus cotangent squared t can become cosecant squared t. And if we look at that, right now, it's kind of where we simplified to, right? We have secant squared t times cosecant squared t. Now, in the denominator, again, if we notice this one, we have a cosecant squared t that, again, similar to the numerator, we could factor out. We're left with 1 plus cotangent squared t. So right now, if we put these back together, right, it's almost like we're bringing them back. We have secant squared t times cosecant squared t. And then in the denominator, we have this cosecant squared t. And if we want to even simplify this, we can make this another cosecant squared t. So we brought these two pieces together, numerator, denominator. Now, what can happen now that we're back to being one fraction? We notice we have some things in common that can cancel out. And then secant squared can be rewritten as 1 over cosine squared. The cosecant in the bottom can be rewritten as sine in the top. And then sine squared over cosine squared is tangent squared. All right, our last example for today is asking us to look at these. And again, I kind of recommend starting these off just as two separate problems. We have cosine of x minus secant of x, which we know is also 1 over cosine. In order to be able to subtract these, though, we need a common denominator, an LCD of cosine. So if we multiply top and bottom by a cosine of x on this one, we get cosine squared x minus 1 over cosine. And we're going to leave it there for a second. And we're also going to look at simplifying the denominator here. So we have sine of x minus tan, which is sine over cosine. And similar to this one up above, we're not able to subtract these unless we have a common denominator. So I can make this have a cosine in the denominator if I multiply a cosine in the top. So we have cosine of x times sine of x, and then minus sine of x all over that common denominator of cosine of x. So right now, if we bring this back to being one fraction, okay, we have cosine squared of x minus 1 over cosine. And then in our denominator, we have cosine x times sine x minus sine x all over cosine. Now, in order to undo this fraction within a fraction, remember you are able to multiply by the reciprocal of this denominator, and this will cancel out our denominator here so that we have just one fraction, which still isn't really super great, but when you multiply by that reciprocal, the denominator, now we have just one fraction to deal with. And since things are being multiplied, what we notice is these two pieces can cancel, and we are just left with cosine squared of x minus 1. And then down here in the denominator, we have cosine times our sine, and then over the sine again. Now, this one we might want to notice here has a GCF of sine in both pieces. So I can take this out and make this sine of x here. And in my denominator, then I have cosine minus 1. Now, very tempting again to want to cancel these out but one is a cosine squared, one is just a cosine. So what we can actually do here is use a difference of two squares. And what we can see here is that we can make this cos of x minus 1, cos of x plus 1. And now that we made that difference of two squares, these can cancel, these two factors, and we're left with cosine of x plus 1 over sine. Now again, you'll often see them like to break this into two fractions. Cosine over sine is cotangent. 1 over sine is cosecant. All right, some pretty intense examples. Thanks everyone for watching. We'll work more with these in class.